my name is Gary Flynn, and I am here today to discuss pretty much all things VRA or Virtualized Automation and Terraform and how they can work together. So you can find me online at the Twitter handle GaryFlynnAU and at garyflynn.com. And to be honest with you, this is my first time presenting, so hopefully the demo gods are being nice to us. Okay, so let's get started with Virtualized Automation Cloud, otherwise known as VRA Cloud. So what is it? Well, basically it enables you to provide a portal to your end users to deploy their infrastructure, both on premises and to any public cloud provider. So VRA Cloud is comprised of three main services, which are Cloud Assembly, Service Broker, and CodeStream. And today we're going to focus on Cloud Assembly, where we set up our infrastructure automation, and Service Broker, where we create the catalog which is consumed by our end users. The third service, called CodeStream, is basically VMware's continuous integration and continuous delivery pipeline tool. So Virtualized Automation is basically available in two different varieties. The first is the on-premises version, known as VRA version 8, and it's also available as a software as a service offering, and that is called VRA Cloud. So the really good news is it's actually really easy to get started with VRA. All you need is a credit card, and you can sign up to the VRA Cloud service. It's surprisingly cheap to learn. So if you do go the VRA Cloud route, currently it's about 3.5 cents US cents per hour per node. So if you're just deploying a couple of machines and then destroying them, it's going to cost you a couple of dollars really. So the service is available globally. It's currently in the US, Frankfurt, Sydney, and Singapore. But of course, you can provision globally to all of the different public cloud regions. And if your organization is already using VRA 8 on premises in your corporate environment, the good news is that VRA Cloud is the exact same code base as the on-premises version, and it's also updated monthly. So it's a really sneaky way to see what new features are coming out before the dot releases are packaged up for VRA 8. So you've probably heard of people talk about infrastructure as code, but what is it? It's basically a way to manage and provision your infrastructure through machine-readable configuration files. And you can store those files in a version control system, such as GitHub, GitLab, all of those, and which enables your team to collaborate together and store those configurations centrally. You can also speed up your deployment times and reduce your risk through consistent builds. And of course, because it's code, you can reuse the same code again and again to deploy different environments, just like across dev, UAT, and of course, production. So when it comes to infrastructure as code, there's generally two different approaches. The first being imperative and declarative being the second. So with imperative language, it's basically defining the steps on how you go from point A to point B. So defining how to get to your end result. Examples of this are, of course, PowerCLI, VRO, JavaScript, and Python. Whereas declarative language, on the other hand, is where you define your end result, not the steps, how to get there. So a few examples of that, of course, are Terraform, Ansible, Puppet, Chef, and PowerShell DSC. So what is Terraform OSS exactly? Basically, it's an open source, free, and simple executable file. We write our infrastructure as code configuration files in what's known as the HashiCorp configuration language, or HCL. But to get value out of Terraform, we need to use something called providers, which integrate with other systems. Now, currently on the Terraform registry, there's over 200 providers available, including all the cloud providers like vSphere, AWS, Azure, GCP, things like Kubernetes, or your monitoring, F5, databases, Artifactory, GitLab, all those sort of well-known products. So the next question is, how does Terraform actually work? Well, we create a Terraform configuration file, which is basically a text file with a .tf file extension, and we specified a provider that we're going to use. For example, vSphere, if we were to create a virtual machine in our vCenter server. We then retrieve any data sources that we need from the provider. So if we were deploying a virtual machine in vCenter, we would need to grab things like the cluster object, the data store object, so that we can reference those when we create our resources, which is the next part. And the resources can be anything that's supported by the provider. So for the vSphere example, we would have things like a virtual machine, distributed port group, or we could have a AMI in AWS or a resource group in Azure. We can then define any post-provisioning tasks using either the local exec or remote exec commands. So local exec commands are commands that are run from your machine locally, wherever your Terraform executable lives, and remote exec commands are run from the provisioned resource. So once we've done all of that, we run the Terraform plan command, which takes our configuration file and queries the provider to sort of gather a view of what the current state of the environment looks like. And it creates a plan on how to reach our desired state. It then generates this plan and showcases that to us, and we can see exactly how many resources are going to be created, updated, or deleted before we run the apply command, where it actually actions the plan. So let's take a look at what that looks like in a demo. So we're going to jump over to VS Code. Is that visible, hopefully?
Yes.
Excellent. So over here, we've got our vSphere provider folder, and we're just going to take a look at our vSphere.tf file. So in here, this is a really simple example where we mention the provider, which is vSphere, the vCenter server we're connecting to, the username and password, and then we can retrieve our data objects. So here we need to grab the data center that we're deploying to, the resource pool, or in our case, the cluster, the data store that we're deploying the machine to, the network, and the source virtual machine, which in our case is a template of CentOS 8. And we can see here the exact name of the data store, the name of the cluster, the name of the network that it's going to be provisioned to. And if we scroll down, we can see our resource. So this is our actual virtual machine that we're going to create. So let's call it VM-1. It's going to have 2 CPUs, 4 gig of memory, and we want it on the data store that we've referenced in our data object previously. It's going to be in the cluster or the resource pool that we've referenced previously, and the guest ID and SCSI type are 2 mandatory fields, so we're going to basically grab them from the template and use those again for our output machine. So we set a network interface as well, which we've defined previously, and we're grabbing the network ID of that. And we want to create a single 30 gig VMDK on that machine. Here we're going to say that we're actually cloning the template, and we reference that through this data object. And we're going to run a customization on it as well. So we set the hostname, domain, and the IP addressing of it as well. So in our console, we can run the initialize command, which is where we actually download the vSphere provider automatically, and we can run our plan. When we do that, it refreshes the state from vSphere and tells us that we're going to create 1 new resource. So we can run our Terraform apply, and that will now go and create that machine in vCenter. So we can jump over here, and we can see that that is cloning the machine. If we jump back to our configuration file, right down the very bottom, we're actually going to run a provisioner at the end of it as well using remote exec. So it's going to connect to the default IP address of the machine that we're deploying with our root credentials, and we're going to run a script called example-script.sh, and that lives in here. And if we have a look at that, we can see it's basically just going to echo out some lines of code for us. So that should take about 2 minutes to create. So we will just let that do its thing, but we can see that it's powering on the machine and it's got all the configurations that we've set. So 2 CPU, 4 gig memory, 30 gig disk, and we're just waiting for the customization to finish. So while that's finishing off, we'll just jump a bit forward with the slides. So that's basically the vSphere provider. Virtualized Automation also has its own provider, and that can be used with your on-premises VRA 8 environments or your VRA cloud environments as well. And it sort of has capabilities broken up into 2 categories. You can set up your infrastructure in VRA 8 using the provider, so doing things like creating your projects, creating cloud accounts, cloud zones, all of your blueprints or cloud templates, creating your image profiles, size profiles, network profiles, all of those sort of day one VRA actions. And then of course, the Terraform provider can be used by your end users to deploy their infrastructure. So they can deploy VMs to the public clouds or your private clouds. They can create Kubernetes clusters and namespaces. They can deploy your code stream CI/CD pipelines, and they can even request VRA workflows as well. So let's take a look at the VRA provider. We'll jump back in VS Code. So we can see that our vSphere 1 has finished. Once it's provisioned, it's connected to the machine and it's run our script as well. So we can see that one's worked. So we'll jump over to the VRA provider. And we're going to create a project. So if we have a look at our project.tf file, again, we've got a provider referenced. In this case, it's going to be VRA. And we're going to connect using some variables, which we've defined in our Terraform TFRs. So this is the name of my VRA environment, my token to connect, the project name we're going to create, the description of the project, and we also want to be able to enable our users to provision to our vCenter, vSAN environment as well as part of this project. So if we have a look at the project.tf file, we're going to need the existing zone, so the vSphere environment. So we're going to retrieve that as a data source. And then we're going to create a resource of our new project. So the name and description, we're grabbing from our variables. The zone, we're grabbing from our data source here and the zone name variable. And we're going to set a couple of properties. So we can say you can have a maximum of 5 deployments. You can have 16 CPU as your limit, 16 gig of memory, and a terabyte of storage. So we're not going to allow you to share resources from this project, and we want to add some users in as well as setting the machine naming template. So in here, we can run our Terraform init to initialize the folder, and it grabs the VRA provider. We can run a plan to confirm that it's just going to create one resource, which it is, and we'll just quickly run that.
Sorry to interrupt you, Gary. We've got a question about what version of the provider you're using.
The latest one, I think it's 0.3.3.
Cool.
Excellent. So if we jump into VRA now, over here, we'll just log in. And as we mentioned at the start, there's the 3 main services. So we're using Cloud Assembly. And under our projects, we will now see our automation user group project. And it's of course added our administrators, our members, and it's mapped the vSphere zone. for us as well, which we can see here, and set our limits as well as our custom naming template. So that's worked. So that's sort of from an infrastructure admin's view, but from an end user's view, it's not really that helpful for us. We're more interested in requesting deployments. So if we jump over to the request deployment folder and take a look at that, in here, we've got our deployment.tf file. And again, we reference our VRA provider using some variables. We're going to grab the project from the variable project name. We grab the blueprint we want to deploy from the blueprint name variable. And we're going to create a deployment, which is going to, if we have a look, we've got blueprint name is GCP machine, and the deployment name is going to be AutoUG deployment. So if we have a look, there's a couple of inputs we need to set on this blueprint. So we're just going to deploy a small machine. Again, it's going to be CentOS 8, and it's going to be in our web tier for our networking. So if we just, again, initialize the folder, and it grabs the VRA provider, run the plan, and we should see it's going to create one machine. And that will run now. So what are we actually deploying? If we jump over to VRA, we can find the blueprint called GCP machine, which is this one. And basically we've got a cloud.gcp.machine object type and a network object type as well. And we have the options to deploy either CentOS 8, Windows Server 2016 or 19. We've got a few predefined flavors we can deploy and some different web tier or some different tiers for the networking that we can deploy to as well. On the infrastructure side, we've actually got all of the different networks created in GCP, and we're simply mapping to those from VRA. So if we go to our deployments, we can see that deployment's being created. And even though it's requested through Terraform, it will still show up as you would expect in the VRA portal. And if we have a look at the history, we can see that that has finished and it's created our machine for us. And if we jump over to Google Cloud, have a look at our instances, we should see that machine running, which we do. And it's grabbed an IP address as well from the correct subnet pool as well. So because I'm not made of money, I'm going to delete that deployment, but because we requested it through Terraform, we're going to destroy it through Terraform as well. So we can do that. Excellent. So let's jump back to the slides for a moment. So that is the VRA provider for Terraform. Now, there's also something that's been recently released called the Terraform service for VRA. And basically, it allows us to run any Terraform code referencing any of the Terraform providers and display that as an option to our VRA consumers. So basically, we can grab our configurations from Terraform and use them on the blueprint canvas, just as we would drag and drop any other object like a EC2 machine or a GCP machine, like we saw just before. And we can, of course, publish that into our service broker catalog, like we can see here. So that basically means that VRA will manage the Terraform state of those provisioned resources as well. So full disclosure, I have thieved these images off the VMware blog, which is referenced here. So if you do want to have a look, check out that link as well. So why do we want to do this? So VRA has a lot of benefits to it, including things like leases and approval policies and all of those sort of management functions that we get. So by putting our Terraform configurations in VRA, we can actually still apply approval policies and enforce leases on those objects deployed through Terraform configurations. And of course, we can actually drag and drop those with the native components that are available on the Blueprint canvas as well. And of course, we can run extensibility on them as well. So we can integrate with things like the ABX or Vero as well. So what does that look like? Let's jump over to VS Code again. And we're going to this time have a look at our GCP request anything deployment. Okay, so this one does take a little while to run. So I'm just going to kick that off now. Help me if I'm in the right folder. Perfect. So what are we doing here? Let's have a look at our main file for starters. So what we're doing is we're using the Google provider this time. So we're not talking to VRA at all. We're going straight to Google Cloud. Now we're going to deploy to London, Europe West 2, and we're going to use the, A zone, and we want to enforce version 3.50 of the Google provider. To talk to Google, we need credentials, which we've got in our credentials.json file here. And we need a project that we're going to connect to on the GCP side, which I've got defined here. If we jump in our GCP TF file, this is where we define all of our resources. So for this example, we want to deploy a auto-scaling web server, basically. So we're going to define our Google computer address, so our public IP address that you can connect to. We're going to create a firewall that says we're going to allow our server port variable, which if we check our variables file, we can see is default to port 80. So we're going to create a firewall that allows port 80 from anywhere. We're going to create a forwarding rule to set that to our compute target from the IP address. And that compute to target is going to have a health check associated with it, which will be checked every 5 seconds and have a healthy threshold of 1 check and unhealthy of 2 checks. And it will basically just check port 80 at the root level is available. We create a Google Compute instance group manager and an autoscaler. So this will say what our minimum and maximum replicas are. So we want to have a minimum of 2 VMs running in the background and a maximum of 8. Our cooldown period is going to be 60 seconds. And we're going to auto-scale based on CPU utilization. So at the moment, it's set at 50%. So if any of the VMs hit a 50% CPU threshold, we will automatically scale up. And what we're actually deploying is our F1 micro machine running Ubuntu 18.04. And it's going to be connected to our home lab network on this subnetwork. And on that machine, we're going to run a startup script, which is basically going to create our HTML file that we can access externally. And it's going to set the port based on our variable server port. So as you can see, I ran this when we started, and it's created all of those different components for us, and it's outputted our public IP address. So if we jump to the browser and put in our IP address, Edge hates me for some reason. There we go. We can see that our web server is up and running. The health checks have passed, and it's passing the traffic through to those virtual machines. And if we have a look in GCP, we should now see that those 2 machines are running, which we've got here, and they're both part of our group manager. So that is all working. Excellent. And it looks like there's a bit of traffic because it's already deploying a 3rd. Excellent. So that is basically deploying to Google Cloud as a auto-scaled web server. Now, today in VRA, if we have a look at our Blueprint canvas, what objects are available natively, and if we duck down to AWS, we can see that there's a load of different AWS services that are available on the campus as native functionality, which is great. But when we get to GCP, we have a lone machine and disk object. So there's not that many integrations today. So to do something like an auto-scaling web server, we couldn't do out of the box with VRA today. But what we can do is we can basically provision this code as a service through VRA. So to do that, we need to update a couple of things. So our credentials.json file, our end users aren't going to have GCP credentials. Instead, it's going to use VRA to connect to GCP. So we're actually going to delete that. And we're going to update our main file and remove out the credentials and project that we connect to. And we're going to save that. Now, if we update so at the moment, all this code is in a Git repo. So we can actually update this and say, update ready for VRA demo. And we can submit that and push it. So now our Terraform configurations to deploy an auto-scaled web server in GCP are within Git. So we can jump over to VRA. We can go to our infrastructure integrations, our GitHub integration, and we can map a new repository for Terraform configurations. And we're going to map that to our repo, which is here. And the folder is the VRA provider. So let's add that. Now what that means is we can go back to our design tab, and instead of creating a new blueprint or cloud template from nothing, we can actually create it from our Terraform configurations. So let's do that. And we're going to call this GCP auto scaled web server. And we'll do that in our management group. Just before we go ahead, I'm going to quickly destroy this one as well. Oh, I should have done that before. Just give me 2 seconds. Just going to put a credentials file back in. VRA provider. Perfect. So we've got our JSON file back in, and we're going to put these back in just so we can destroy the deployment, sorry. Excellent. And we won't push that to Git, so Git will have the correct version. So that's fine. So we can, back in VRA, we're going to create our GCP auto-scaled web server. We'll go next. And we're going to connect to our UAG demo repository. And we'll grab the most recent commit, which is our update ready for VRA demo. And we're going to do the GCP request anything deployment. Now what that does, it will basically look at our Terraform configuration files and go, okay, you've got the Google provider referenced, and you're talking to these zones and regions and this version. So it's also picked up our input variable of server port, and it's going to output our public IP address as well. And of course, we can set our Terraform version to the latest 12 release. So we can create that. And that gives us our infrastructure as code blueprint, and we can deploy that. So let's go automation UG demo. And this time let's do port 8080. So we'll just make sure that destroy is finished, which it has. So we'll deploy that. If we jump into GCP, we should see those base instances destroyed, which it has. Cool. So if we have a look at our history tab, once it kicks off, we'll be able to see all of the lifecycle events that we do with a normal VRA deployment. Try that again. History, there we go. So we can see that it's run the plan command, just like we would do in VS Code in our terminal. And we can see the logs for that of exactly what's going to be created. We can see that then it's going to do all of those VRA kind of things, like checking for approval policies. For us, we don't have any. And we can see the logs for the actual apply command as well. So we can see it initializing, grabbing the provider, and then creating all of our resources as well. So we'll just let that run for a second. And if we jump over to into GCP, we can see our instance groups. So we can see our group managers being created. Excellent. Again, you can see the auto scaling rules. So at the moment, it's 50% utilization on our pool. We can see our health check, which again is checking port 8080 this time, and it's doing that one healthy threshold to consecutive failures, and it's checking every 5 seconds. And hopefully that is complete, which it is. So from this, we can get our output, which is our public IP address. And while we're waiting for that in the GCP land to finish up, we can actually have a look at our topology. So these are all of the different resources that we deployed. So you can see in here all of our outputs as well. So you can easily get the IP address that was deployed, and we can see all of the different objects. So we've got our IP address, we've got our autoscaler, we've got our firewall, the forwarding rule, the health check, all of those different components. So let's say hypothetically you had a Terraform configuration to deploy this in AWS, and you were deploying a couple of virtual machines as well. If one of these was the virtual machine object type, then you would actually be able to, VRA will recognize that, and it will treat it just as though it was any other AWS machine. So you could actually perform all of your day 2 actions on that object as well. So you can power it off, power it on, restart it, resize it, do sort of all of those normal tasks that you would do on that object type. And if we jump over, we should now see. Keep in mind that GCP does take a minute or two for it to come up. So we'll give that a minute. And of course, it's the custom port. We set it as 8080, so 80 won't work. There we go. Perfect. So now we can basically extend VRA beyond what it's natively capable of. We can actually say you can deploy a auto-scaled web server to GCP from VRA. And we can do that in what's called the service broker. And we can see my catalog of all of my objects that we can deploy. And I can present a GCP auto-scaled web server through here to be consumed by the end users, just like any of my other sort of deployment options that we have. So that is the demo. Let's quickly jump back to the slides. And that is pretty much us. So if you are interested, I'm going to put up all of the different Terraform configuration code up on that link probably tomorrow. And if you do want to get started with VRA Cloud, like I mentioned, it is really simple. The link's just there. And again, Terraform is fantastic. It's really simple to get started. So grab the download and start having a play. And if you are using the VRA provider, there are plenty of examples that VMware actually provide at that address as well to get started. So that's pretty much it. Thank you for listening. And does anyone have any questions?
So Gary, Garano, I'm not sure how you say that. He's been on and he said that it seems to be presented as a bunch of cool technologies, but he's wondering what the goal is and how it relates to business needs.
Yeah, excellent. So I guess the point is that with Terraform especially, we can basically provision any infrastructure. We can do that consistently through code. We can manage it through version control, and we can it's just a lot simpler. So the point of the final demo was to show that although something isn't possible in VRA itself, we can leverage the benefits of Terraform and actually go and provision all of those things that we can't do using Terraform. So yeah, basically the example of deploying a auto-scaling web server, we can't do that natively in VRA, but with Terraform offloading to there, we can basically give our end users more options for deploying.
And I guess it's also another method of consuming the platform. So as well as the GUI and the client, the API, we're offering Terraform to any developer types out there who don't like all the others and they just love Terraform.
Exactly.
I have a question, if you don't mind. So I'm using an older version of the provider, honestly, because I'm still running an older version of VRA 8. So we're in the process of upgrading. It's just a long process for us. We have multiple VRAs that we've kind of federated, so it's a longer process. One of the biggest issues I've noticed that if we have some people that do larger deployments, so they will do a count of deployments, so there'll be like 50 machines in a deployment, 5 machines. And now if something hangs up on one of them, when we're doing this, like they can go into VRA or we have a custom portal and they can knock one out. The biggest problem with that is the provider seems to look at the state and not look back at the like the deployment to see if any changes have been made, which then makes it doesn't update. I found the kind of a bad workaround to get it around that, and I might open up a bug. I'm waiting till I upgrade to see. I was wondering if you noticed if that's fixed in any of the newer versions, or if you've noticed that at all.
Yeah, I personally couldn't say definitively, but I would test with the newer version, and if not, definitely file that as a bug, because I don't think that's expected.
Yeah, and so that, I mean, it becomes a problem with us because, example, when you're doing only a couple machines, it's fine, but if I have to destroy 250 machines, that's 30 minutes to an hour to bring back up, plus it ruins our application at the time, and that's just one stack. So yeah, we're looking at different ways. Like literally I'm still running 8.0.1, and with it I can put a fake input in there and it'll automatically refresh. So like if I put in a variable in, like for example input, and just put in there and it doesn't exist, it'll actually go back and check. But if that's not there and it matches whatever's in the blueprint or the catalog item, it'll go through and actually it'll just use the state at that point.
Yep.
Don't know why. So, all right. I appreciate your guys' feedback.
Interesting. It's not something I've come across, so I am wondering if it is fixed in a newer version of the provider.
Yeah, I don't know what versions some of my users are using because I'm not as, like, I don't check with them, but I know like I didn't want to put in a bug with using such an older version of VRA. Once at the end of February, when we're up to 8.2, I wanted to see if it was fixed in that with a newer version of the provider, if it fixed it or not. So before I started bugging Deepak and them to fix it. So, all right. Thank you so much.
No worries.
Yep.
Does anyone have any other questions?
Yeah, cool. Quick question from my side. So how do you guys manage state files and share them across teams?
Yep. So if you're using the Terraform service with VRA, so VRA itself will manage the state file. If you're just using VRA provider to consume VRA, then I guess the state files managed however your sort of corporate environment would manage that.
Okay, cool. Thanks.
I guess you're getting into things like Terraform Enterprise or Terraform Cloud at that point, I think.
Yep.
Okie dokie. Well, thank you very much, Gary. That was an amazing talk and demo. I don't know you guys, I thought it was amazing. So well done.